when we evaluate limits, we can evaluate limits graphically by just looking at the graph. We can also evaluate them numerically or tabularly. These are basically synonyms for us. When we think about numerically analyzing something, we think about looking at the numbers. So we're going to be looking at a table. Now, why would we need to do that? If we take a look at this limit, what I would normally do in evaluating a limit is I would take that -3 and I would just plug it in everywhere I see an x. In a continuous function, I'm going to be able to find that value. But when I take that -3 and I plug it into this, I can immediately see that I end up with a 0 in the denominator. Well, a 0 in the denominator is not going to help me, right? That's an undefined scenario. Also, if I plug in a -3 up top, I end up with 1 minus 1. So I don't just end up with division by 0, I end up with 0 over 0. And that's problematic. But it also is what we determine to be an indeterminate form. We're going to talk more about that later. So it means that we can find a limit, so we're going to have to use another way. So one of the things that we do is we can use a table. Now, if you looked at this graphically, you wouldn't be able to see the fact that there is a hole. So what I'm going to do is I'm going to show you what the graph looks like. Now, this is the Calculate 84 app. It doesn't work exactly like an actual 84, but we're going to be able to get a pretty good feel for this. So what I would do is I would take the function and I would go ahead and type it into y1. Now, I like using this alpha y equals. And if you click on number 1, which yours probably doesn't say fraction, it probably says n divided by d on it. But if you just click on that first one, it's going to basically give you a numerator over denominator, so you don't have to worry about parentheses. I think that's a really nice feature on these 84s, so I'm going to go ahead and use that. You do have to get out from underneath the square root, so make sure you click the arrow button to get out from underneath the square root. You can see that pretty clearly though. And then you're going to have x plus 3 in the denominator. So that's what I want to graph. That's what I want to look at, the table. But let's go ahead and look at the graph so we have an idea. Now my window's been adjusted just a little bit, so let me go back. If you haven't looked at your window at all, your window probably looks like this, right? -10 to 10. Now I'm not going to go anywhere past -4 because of the situation with the domain, right? I can't put in a -5 because my square root's going to have a negative in it. So all this is going to be gone. My domain starts right there at -4. But right here at -3, I can't see that there's a problem, right? That doesn't look like there's an issue there. But I know that if I plug in a -3 into that fraction, I get 0. So something's got to be going on, but you're not going to be able to tell that by looking at the graph. So what we're going to do is we're going to look at the values in the table. So let's go back to the table here. I'm given some sorry about that. I'm given some very specific values to look at because I know the issue is right around -3. So I don't need to just go to the table and look at generic integers, right? I want to look at -3.1, -3.01. So how do I do that in the calculator? Well, the first thing that you could do is you could go to the table set and you could change this independent to ask. So if you went to ask and then you went to the table, in a normal calculator situation, you would be able to type in whatever values you wanted. The Calculate 84 app does not work that way. So I'm going to go and show you another method that I think is a good workaround, and it's also just a good thing to know because in the future we are going to use this piece. So let's go back to, I'm going to quit that. I'm just going to go to my home screen. And what we're going to do is we're going to use the alpha F4 feature. It gives you a list of y situations, right, that we had in our graphing screen. So I want to pick y1 because that's what I have typed my function into or my graph into. And so if I want to plug a value into y1, if I use parentheses correctly, I could plug in a -3.1. And what this screen is telling me to do is take a -3.1 and plug it into whatever I've plugged into y1. So when I press enter, now I've evaluated that. If you press second enter, it will repeat that, and then I can just go back and add a 0, and then I press second enter again, and I go back and I add another 0. So pretty handy feature, and plus I have the list of answers right there for me. I really like the table set ask feature as well, but if that doesn't work, this is a good workaround. So let me go, I need the 2.99, right? So I'm gonna go, where's my little backspace there? So I'm gonna go delete, delete, delete. All right, so -2.999, and then -2.99. Oh, I didn't press second enter. I gotta clear that. All right, so second enter, go delete that piece, and then second, enter, and go delete one more. Oh, try again. Second, and then delete, delete. All right. So that gives me the values that I'm working around. So I'm going to go ahead and fill in this table. You always have to keep 3 decimals in this class, but whenever we're working in the middle of a problem, you really want to keep more than that because your final answer is going to have to be accurate to at least 3 decimals. So we're going to always try to keep 4 or 5. If we needed to do something with it in the calculator, then we would actually store the value. But for right now, I'm going to keep 4 or 5 decimals, and I'm going to go ahead and fill in the table accurately. So I have something to look back at, taking notes, right? So essential to be able to take good notes so you have something to look back at. All right, one more here. So 0.49876 and then 0.48809. So this is in a timeline or a number line order, excuse me. So this is obviously in a number line situation where we've got the -3 right there. Okay, so the idea is this. What am I approaching? I know that I don't have a value at -3. I know that, in fact, if I were to graph this, and I'm not going to do it really accurately, but if I were to graph this, I've got -3 here, I would actually end up with a hole. So it would end up looking something like this. I would get a hole, and then it would stop. Right there at -4. But I know I don't have a value. I don't care about the value. I care about what I'm getting closer and closer and closer to. And numerically, I can see that value as we look at this from both the right and the left. I'm getting closer and closer and closer to a half or 0.5. And obviously, either one of those is perfectly fine for you to write. That's the way we analyze a limit numerically.